Alright, you guys, this is me continuing section 3.3. We're going to look into the remainder theorem and the factor theorems. And that's the only part left of this lesson before we're done. So you already saw how we do division, long and synthetic. So for these two theorems, it's actually very useful to just use the synthetic division. You technically can use the long division, but it's, again, long and tedious. So synthetic is actually a lot better. So please practice as many synthetic division problems as you can, even if the homework isn't long enough. I usually don't like making the homework too long because that's kind of too hard, especially since it's graded. But I still want you to keep practicing as many problems as you can. Alright? So, now let's go back to our section. So, the remainder theorem has a specific verbiage that I want to give it to you, and it's in your notes already. So, if you have the notes in front of you, you technically don't have to write this, but I'm going to write it down anyway. And it says, this is the remainder theorem. Alright? So, it's... Alright, so the remainder theorem says that if a polynomial f of x is divided by x minus c, right? So, which is, by the way, the usual divisor we use for synthetic division, yeah? So, if it's divided by x minus c, right, then that means that the remainder is f of c. So what does that mean? It means that when you do a synthetic division or long division, but you're dividing by a divisor that is in the form of x minus a number, right? So x minus c. If f of x is a polynomial and is dividing by x minus c, then that means that the remainder, so after you are done conducting a division, the number we have left that we usually divide by the divisor, right, that remainder, equals f of c. And what I mean by f of c is that if you grab the number over here, the one you're going to divide by in the synthetic division, or the value of x if you solve for this, right, that's c. If you grab it and you plug it into the original function, the answer is going to equal the remainder you get. Make sense? So the remainder of that division is going to be the same thing as the value of that function at that value c. Okay? So let me give you an example and see what that means and how we can use it. Right? So here's the function for you. The question says f of x equals 5x to the 7th degree minus 3x to the 5th power plus 2x squared minus 1. Alright? So the highest degree we have here is 7. We have a 5 and we have a 2. You don't have a 6, you don't have a 4, you don't have a 3, you don't have 1 power, but that's okay. We can fill those in. Now, the question is asking you to do the following. Given this function, use the remainder theorem to evaluate f of negative 1. Alright? Now, here's an easy step. Grab the negative 1, plug it in here, find the answer. Done, right? Well, true, that would be the answer. And if you had done that, you would get the right answer. It's just that if you do that, you won't get credit for the question because I'm asking you to use the remainder theorem. Alright? So, I need to figure out what f of negative 1 is. But notice, I also didn't tell you what I'm dividing the function by. But because I have this remainder theorem, you know that f of c is the remainder, right? And this c would be the same c value you have inside your divisor. So that means that whatever is inside these parentheses is the number I'm dividing by. Make sense? So I'm just going to grab the negative 1 and place it inside my little window. And then I'm going to fill in all of these inside the division. Alright? So we start at the 7. There we go. Okay, so the coefficient of that 7, x to the 7th degree is 5, right? And then next would be to the 6th, which is not here. So we write down a 0. Next would be to the 5th, which is here. And it's a negative 3. Next one would be to the fourth. We don't have that one, so 0. Third, we don't have it, 0. Second, we do, which is a 2. First, we don't have it, another 0. And then the number, which is -1. So this is my function. Now, leave room, draw a line. Okay, now, arrow goes straight down. 5 is placed in the answer. And now we start multiplying. 5 times -1 is -5. You place it here. We're adding. 0 plus -5 is -5 still. Now -5 times -1 becomes a +5, right? So -3 plus +5 is going to be a +2, right? Now 2 times -1 is going to be a -2. The addition between 0 and that -2 is going to give you a -2. -2 times the -1 is going to be a +2. 0 plus 2 is still 2. Again, 2 times -1 is going to be a -2. The subtraction between these two gives you what? 0. 0 times -1 is still 0. 0 plus 0 is 0. 0 times -1 is going to give you another 0. So the answer over here is going to be 0. And then 0 and -1 added together gives you the answer -1, that being your remainder. Now, you don't have to translate this into a function and write down the answer for me, because that's not what that question asked. The question only asked you to find what f of -1 equals, and according to the theorem, the remainder is f of c. So the remainder is -1, which means f of -1 is -1. It just happens to be the same number. So it's not always going to match, right? So this time it's -1 for both, but in other cases you could get 0 or you could get 7 or whatever. That's the remainder. Alright, so that was the remainder theorem. Let me give you another one, or another use of it. So let's look at this example. In this question, it's asking you to do the following, which is number 7 in your note set, by the way. It's saying, use the remainder theorem to show that the square root of 5 is a 0 of f of x, right? And the f of x they gave you is x cubed minus 4x squared plus, minus 5x plus 20, right? So we have my f of x, and it's asking me to prove, right, to show that it is a 0, which means the question is telling you that the square root of 5 is a 0, and they want you to show that. So it's not determine whether. So the answer is not going to be no. You already know it's a yes. You just want to show me why it's a yes. Make sense? So since square root of 5 is a 0 of this, okay, that means I'm going to use it as what? As my divisor. So this is the function. What I'm going to divide by is the square root of 5 itself, right? And according to the remainder theorem, according to the remainder theorem, since dividing by x minus c, then the remainder is going to be f of c. That means that if I'm dividing by this root of 5, and you plug in root of 5 into the function, the answer is supposed to be what? 0, right? Because it's a 0 of the function, yeah? Which means the remainder needs to be 0. Make sense? So let's do that. Okay, in my little window, we write down the square root of 5. Now it looks like a box. But yeah, let me make it a little longer. Okay, now I'm going to write down the coefficients of the numbers I see here. So first one, x cubed. It has a 1, so I'm placing the 1. And that's just the 1. This is a scribble. Please ignore that part. Actually, I'll just do this because I don't want any mistakes. Okay, so 1, just the 1. And over here, for x squared, which is the next term, we have -4. So we place the -4. Next one is the -5 for x to the first power. So it's -5. And lastly, it's the +20. So place 20. Alright? Leave room. Draw a line. Now you grab the first one and you take it all the way down. 1. And then we'll start multiplying. So 1 times square root of 5 is going to be square root of 5. I know this multiplication is going to be a little nasty since we have a root, but bear with me, okay? Now, we have the addition between -4 and square root of 5. So it's basically -4 plus the square root of 5, whatever the answer is. Write it down like that, okay? So now we're multiplying this times root of 5, okay? So when you multiply root of 5 times this, which is basically a pair of parentheses because there's two values, they're added, you don't have any x's, so nothing to worry about, they're just numbers. But to make things easier, I'm going to multiply them separately, right? So you have root of 5, oh, I'm pointing to the wrong one, root of 5 times the -4 is going to give you -4 times root of 5, right? Plus root of 5 times the other root of 5, and when you have two square roots multiplied together, what happens? That basically becomes a square root of 5 squared, right? That means I have square root of 5 multiplied by itself. So you have a square root here and you have a squared, which means they're gonna cancel, right? So the end result is going to be just 5. The root and the square cancel each other. Make sense? So over here, we have an addition between -5 and -4 times root of 5 plus +5. So the +5 and the -5 are going to cancel, and you're going to end up with the -4 root of 5. Okay? So this is the part that comes here. These two cancel each other, and you end up with that as a result. So far, so good. If that was confusing, please pause the video and re-listen to that explanation again. If you still don't get it, let me know in an email and send me the timestamp of the video. Alright? Now, over here we have -4 root of 5 times root of 5. So I'm going to multiply these together again. So the 4 remains the same, multiplied by root of 5 being squared, because I'm multiplying the square root of 5 times it, right? And the squared with the 5 cancel, correct? Which means this is basically -4 times 5. So multiply together, 4 times 5 is 20. With the negative, the answer is going to be -20, right? So that's the number we have here. It's -20. And I'm adding -20 plus +20, and the answer is going to be 0. So that is your remainder. That means that root of 5 is indeed a remainder of the function, and the remainder theorem proved it. Make sense? Now, let me take a look here. Okay, so that was the remainder theorem. Before I move on, let me give you a chance to copy these. I'm going to scroll up a little. So this is the first problem we did. I'll give you a few seconds to look at it. Alright, just pause the video. And here's the second problem. I'll write it 2 over here. This is the second problem. Okay? Alright. Now, let's look into the factor theorem. Here we go. So for this theorem, the idea is actually very simple. The factor theorem says, So the factor theorem says, let f of x be a polynomial. Alright, let it be a polynomial. Now, there are two things you need to know. One, if f of c, okay, notice I'm plugging in that c we've been talking about a few times in this section, yeah? So, if f of c equals 0, then x minus c is a factor of f of x. Which makes sense, right? From what we saw in the previous example using the remainder theorem. You had a function, and I told you that the root of 5 is a 0 of that function, which means it factors it, right? It divides it neatly, that it gives you 0, and the remainder was 0. That means f of c is 0. So this is basically telling you that once you're done doing the division, if there is no remainder, that means what you divided by, x minus c, it was a 0 of the function, which is very true. So this is the first statement the factor theorem is telling you. And by the way, that's probably why they call it the factor theorem, because when you have a polynomial and we want to find the zeros, what do? We factor it, right? So once you factor it, you come up with the pairs of parentheses that once you multiply them together, you end up with the original polynomial. So this is basically saying if there's no remainder, that means the divisor was one of those pairs of parentheses factoring the function. Make sense? Which is why it's called a factor. Alright, so that was the first one. The second rule says that if x minus c, so the divisor, is indeed a factor of f of x, right, then f of c is going to equal 0, which is also very similar to the remainder theorem. Again, the remainder theorem says that f of c, if a function is divided by f of c, then by x minus c, then f of c is going to equal whatever the remainder is. So this is telling you that if that remainder is 0, that means you divided by a factor of the function. And if you're dividing by a factor of the function, then that automatically means that the remainder is going to be 0. So these two kind of say the same thing, but in opposite directions. Make sense? So that's what the factor theorem is about. Now let me show you an example here. I'll pause a little so you can copy this if you'd like. Alright, here you go. So this question says, use the factor theorem to determine. Alright, so in this one I'm asking you to determine. That means the answer could be yes and it could be no. So I'm asking you to determine whether x plus 4 is a factor of f of x. And the f of x is what? 6 x cubed plus 11 x squared minus 60x minus 32. Alright, so this is my function. And I want you to tell me if this right here is a factor of that function. So let's divide by it and see if the remainder is 0. If it's 0, then the answer is yes. If it's not 0, then the answer is no, obviously. So let's do that. So what we're dividing by, since the form is x minus c, and over here we have x plus 4, that tells you that the value is going to be what? Negative 4, right? Now let's write down what the numbers are going to be. You have 6x cubed, so the first one is 6, and then 11x squared, so the next one is 11, negative 60x, and then negative 32. Okay? Now, leave room, draw a line. I'm going to grab a 6 and move it all the way down. Okay. So now we start multiplying. 6 times 4 is going to be what? 24, right? And since it's negative, 24 is going to be negative. Now we add 24, or negative 24, plus the 11, and that's supposed to give you negative 13. Now negative 13 times negative 4, they're both negative, so the answer is going to be positive. And 4 times 12 is 48, plus another 4, that's 52, right? So it's a positive 52. So negative 60 plus positive 52 is going to give you a negative 8. And again, negative 8 times negative 4 is going to be a positive, and 8 times 4 is 32. Positive and negative 32 added together is going to give you the remainder of 0. So since the remainder is 0, then that means that x plus 4 is indeed a factor of f of x. Make sense? And that negative 4 is a 0 of the function. Alright, so that was your factor theorem. Let me maybe do one more, because I think technically if we were in class physically, I have about 10 minutes left. So I'm hoping that if I show you as many examples as I can, that would help. And hopefully I can do both 10 and 11, so we'll see. Here you go. So for this one, we have the function f of x equals 4x to the 5th power minus 24x to the 4th power minus 3x to the 3rd power, so we're good so far, plus 18x to the 2nd power minus x to the 1st power plus 6. So they accounted for every single x possibility. You have 5, 4, 3, 2, 1, and 0 powers, so we're not missing a single value. And now given x minus 6 is a factor, right? So given that x minus 6 is a factor of this function, the question is asking you to factor that function. Now please note, over here you have x to the 5th. Since it has the 5th degree over here, so that tells you what? It tells you that your function is going to be factored into how many pairs of parentheses? At most 5, right? Because you're going to have 5 zeros. Let me show you all 5 there. Right? So since you have to the 5th degree, that means you could possibly have 5 zeros. Therefore, you're going to have at most 5 pairs of parentheses. Now, the reason I say at most is because it is possible for some values to repeat, or you might get something complex, which I think is the case in this one. But we'll see. So first thing you need to do is that they told you this is a factor. So you already know this is one of those 5. One of those 5 pairs is going to be x minus 6. You just need to figure out the remaining 4, right? So for this one, since this is my factor, you already know this. So that means if I divide by it, I'm going to get 0 as a remainder, and I'm going to reduce this into a 4th degree instead of a 5th degree, right? So basically I'm factoring this out, which is the goal. So let's do that to simplify this, and then from there we'll factor it by hand. Make sense? So over here you have x minus 6, which means I'm going to divide by positive 6 since it's a x minus c form, right? Now I'm going to write down the coefficients. So we have the 4, we have the negative 24, we have the negative 3, we have the positive 18, we have the negative 1, and we have the positive 6 without the sign. There. Yeah? Leave room. Draw a line. Arrow goes down. The first one is 4. So 4 times 6 is what? It's going to be 24. Added to the negative 24, the result is 0. 0 times 6 is 0. Added to the negative 3 is negative 3. Now, negative 3 times 6 is going to be negative 18. Again, it cancels it out, you end up with 0. 6 times 0 is 0. Negative 1 plus 6 is plus 0 is negative 1. Negative 1 times the 6, it takes you back to what? To negative 6. And when you add the 6 and the negative 6 over here, the result is 0. So they were right. X minus 6 is a factor because it gave me the remainder 6, right? Now I need to figure out what my function looks like. So let's do it from the left side. It started as a 5th degree. That means after you're done dividing, it's going to be a 4th degree because we already factored one of them out. So we have x to the 4th, and the coefficient 4, plus, this is 0. Oh, so now it makes it a minus. Okay, minus 3x squared, because the x cubed went away, right? This is a 0, so x to the 1st is no longer there. And then minus 1. This is your function. Plus 0 as a remainder. Right? So you don't have to write this down, by the way. This is just my way of telling you that we had no remainder. So this is a result of the function after we did the division. So basically, this f of x now looks like this. F of x equals 4x to the 4th minus 3x squared minus 1 times x minus 6. Right? And the reason I wrote the x minus 6 is because I'm saying that this right here is actually f of x. That means it's still multiplied by that value. We didn't divide by it yet. I just needed to do this division to figure out what the function looks like once you factor out that x minus 6. Make sense? So now that I did that, I'm gonna grab a new page, but let me I do this and pause a little so you guys could copy all of this. Alright? Okay. So now that I did that, from here I'm gonna continue factoring the rest of the problem by hand, which shouldn't be very difficult since we've done a lot of practice problems on factoring before. Over here we have x to the fourth minus 3x squared minus 1, and then it's multiplied by x minus 6, right? This is my function. Now I need to factor this part out, yeah? Now remember, when we used to factor out quadratics, what do? You split it up into two pairs of parentheses and you factor it out and you see how it turns out after that, right? Well, this is exactly what I'm going to do here. But if you remember when we said we have a trick called u sub, where you substitute a value of x and you place u instead. So for example, I could call u to be x squared. And the reason I think I can do this is because you don't have x to the third and you don't have x to the first. You just have x to the fourth and then x to the second and then the 1, right? So if I turn the x squared into a u, that means that over here, this function now looks like this. You have 4 times u squared, because x squared squared becomes x to the fourth. Make sense? So 4u squared. We did a problem very similar to this in section 1.4, if you guys remember. So it's 4u squared minus 3 times just u in this one, minus 1, and then we said equal to 0. Okay? From here, I'm gonna factor. So first thing you need to do is split it up into two pairs of parentheses and it equals 0. Now, you have a u being placed right here and a u being placed right here since it's squared. Okay? Now we do have a coefficient. It's 4. So you have two options. It's either going to be 2 and 2 or 4 and 1, which you can determine after you figure out what this number here is supposed to do. Okay? So over here, this is supposed to be the multiplication, correct? The number on the far end, that one is the result of the multiplication between these two numbers. Now, since it's 1, obviously you don't have any other options. They're both going to be 1, right? So 1, 1 is negative. That means 1's positive, 1's negative. So that was easy. Now we need to figure out where the 4 goes. If it's a 2 and 2 or 4 and 1. And if you look closely, it's supposed to be a 4 and 1. Why? Because the difference over here is 3. Had it been 2 and 2, this would have been either 4 or 0. It wouldn't have been there, right? If these two were identical, that would have went away. But since we have a 3, the only way to get that is if you subtract 1 and 4. Make sense? So that means one of them is going to have the 1 and one of them is going to have the 4. Now, the one with the negative sign is going to be the one with the 1, and the one with the positive sign is going to be the one with the 4, because the number you place here is multiplied by that value and the number you place here is multiplied by this value. Make sense? So since the 3 is negative, that means the 4 gets multiplied by the negative 1, which means it goes over here. Make sense? And over here you place just the 1. Okay? So my two pairs of parentheses now say what? We have u minus 1 equals 0, which if you solve it, it becomes u equals 1. Yeah? Or, yeah, 4 u plus 1 equals 0, which if you move it to that side, it becomes 4u, and maybe this to make a difference between my 4 and the u. 4u equals negative 1, right? So divide by 4, divide by 4. This goes away, and you end up with, u equals negative 1/4, correct? Okay. Now on this side, since the answer is in terms of u and I need it to be in terms of x, that means I need to plug in the x back. And I said that u equals what? X squared, right? And since I'm saying u equals 1, that means x squared itself equals 1. So if you take the root like this, then you end up with x equals positive and negative 1. So So those are two answers. Now let's do it here. Over here, I'm going to plug in the x squared again, negative 1/4. Take the root, and we have a problem. Because over here, you end up with what? With a negative underneath the root. That means this one is not solvable. It's going to give you a complex answer. Make sense? So, now let me go back to the original question. This is the original form we had. I'm just rewriting. Times x minus 6. Yeah? This is what we started with. Now, after the factoring I just did, I factored this into two pairs, right? One was 4x squared plus 1. I just removed the u and placed the x squared back in. And the other one was x squared minus 1. And you multiply by the x minus 6 because it's part of the function. It was already factored, that's why I didn't write it above. But now that we're done, I'm writing it back in. And then after I place the x squared, this right here, as you can see, we can still factor. So the first one stays as is. 4x squared plus 1. We're not going to touch that because when we tried, it turned negative. That's a problem. We can't do that. So we're not going to touch that one. But for this one, you can still factor the x squared. So this one is going to become positive and negative 1, which means it's either x minus 1 and x plus 1. And then times the x minus 6. Right? So this one's split into those two. That one's still the same. So we have 1, 2, 3, 4 that has the second power because you can't factor this. Make sense? So this is your function factored. Now, I'm gonna do this so you can see the first half. Try and copy. Alright? And here is the second part. Okay? Now, so with this one, as you saw, we used the factor theorem to try and factor the function. We got the one pair out and we factored the rest by hand. Now I want to show you how everything we learned so far can technically help you put the function back together, which is actually incredibly easy, which is question 11. So bear with me here. If I give you a function and say, I want you to write down a function for me, and the formula, by the way, could vary depending on how you looked at it, but the question says, write a polynomial of degree 3, so I'm telling you it has degree 3, so it has a third power, yes, that has two zeros, multiplicities of 2, so I'm saying that the zeros, I'm already giving you the answers, yeah? I'm giving you what the solution for x is. That's what the zeros are. So I'm saying that the zeros are 2, the number 2, with a multiplicity of 2, and the number negative 5 with a multiplicity of 1. So 3 degree, so that means the polynomial has a third degree, which means it has how many answers? 3, right? So I'm saying that out of those 3 answers, 2 of them are 2 and 1 is negative 5. Make sense? So from this should basically tell you that I'm basically telling you that x is 2 and negative 5, right? That's what this means. The fact that there's zeros, that means they're solutions of x. So I need you to backtrack. This is basically you undoing a solution of a polynomial, because the question is asking you to write the actual polynomial, which is very easy if you have the zeros. All you have to do is rewrite this in terms of parentheses. So before we get rid of the, usually when we have parentheses and we want to solve for x, you grab each one, you set it equal to 0, and you solve for x, right? Well, for this one, I'm going to undo that solution method. So for example, x equals 2, I'm going to grab a 2, move it to the opposite side, and it becomes x minus 2. Make sense? So that's your first pair. And over here, negative 5, so that means x equals negative 5. I'm going to grab the negative 5, move it to this side, and it becomes x plus positive 5. Like that. So these are my 2 pairs. So I have 1, 2 solutions. The question said third degree, so don't forget that the 2 has a multiplicity of what? 2, right? That means that this pair is there twice. Make sense? So you have this pair multiplied by itself and then multiplied by x to the 5th power. So from there, all you need to do is just multiply these 3 pairs together to get what the final polynomial is going to look like. So first let's start with squaring the x minus 2. So it's going to be what? X minus 2 times x minus 2 times the x plus 5, right? So I'm doing these two first. So x times x squared, x times negative 2 is negative 2x, negative 2 times x is another negative 2x, and negative 2 times negative 2 is a positive 4, right? These are my values of the first pair, and they're multiplied by x plus 5. Okay, I'm just going to rewrite because these can be added together. So you have x squared minus 4x plus 4 times x plus 5. Alright, now from here I'm multiplying this in. So again, x goes 1, 2, 3, and the 5 goes 1, 2, and 3. So x squared times x gives you x cubed. X times negative 4x is going to be negative 4x squared, and x times 4 is going to be positive 4x. 5 times x squared is going to be negative 5x squared. Oh, sorry, positive 5x squared. 5 times negative 4x is going to be negative 20x, and 5 times the 4 is going to be a positive 20. Adding them together, this gives you x cubed. You have negative 4, positive 1, that gives you a positive x squared. You have 4 and negative 20, that gives you negative 16x, and plus 20. This right here is the final result. That's your polynomial. Simple. And if your answer looks different, it doesn't mean it's wrong. It could be wrong, but it doesn't mean it's necessarily wrong, because it is possible for you to come up with multiple answers. The answers could vary depending on how you figured it out, but the final conclusion should be very similar. And if you did receive a different answer, email it to me and I'll tell you if you got it right or wrong. Okay? And yeah, that's it.